Hello students, welcome to Tuteetute. So in our 500 questions, next set of questions we will solve in this session. Okay. So the first question in this, at parallel resonance condition, the power factor is. So power factor they are asking at resonance condition, but which resonance they have mentioned. So generally we used to learn about the series resonance, but about the parallel resonance, so nobody will practice generally, but there is no much difference of concept for the series resonance circuit and parallel resonance circuit. So even if it is a parallel resonance circuit, so okay, one resistor, so one inductor and one capacitor, if you connect like this, it is a parallel circuit which can produce the resonance. Okay, so and we need to energize this using a source, energy source, which is generally an AC source. Okay, so we can use the current source for easy calculations. Okay, so here also under the resonance condition, so the entire reactance, otherwise we will be calculating the admittance. Okay, so because it is a parallel circuit, calculation of admittance is easy for this. For the series resonance circuit, we used to calculate the impedance. Here admittance we will be calculating. Admittance generally it will be having one real part and one imaginary part. So to get the resonance condition, okay, so imaginary part must be equals to 0. Okay, so like this we used to do. Okay, so even for this also same only. So real part and imaginary part will be there. Imaginary part if you make equals to 0, you will get the condition for the resonance. Okay, so even here also we need to do the same thing only. Okay, so at parallel resonance they are asking about so power factor. What is the power factor? So what is power factor generally? Power factor is nothing but so unity, that's it. So whatever it is, whether it is a series resonance circuit or parallel resonance circuit, the imaginary part becomes 0. Imaginary part becomes 0 means, so the entire power factor we can give it as the active power to the complete power is nothing but so the power factor. What is the power factor? How much is the active power in complete power or complex power is nothing but power factor. Okay, at what factor we are utilizing the power. Okay, so what power you are utilizing? We are utilizing only active power. So how much active power is there in the complex power is nothing but our power factor. Okay, so anyhow, so some definitions will be giving like this. Okay, so cos of angle difference between voltage and current, it's correct only. Okay, it's a formula for the power factor. Okay, so how to calculate power factor means this is the one. Okay, this is not the definition of power factor. What is power factor? Power factor is nothing but at what factor, okay, at what rate the power is getting consumption, power consumption is happening in the entire power or complex power. That is nothing but our power factor. Okay, so even if only active part is present in A plus JB, if only active part is present, then only active power will be present. So entire power is also equals to P, then you will be getting as 1. That is the answer. Okay, so unity power factor will be the answer for this one. Okay, so answer is B. Okay, next question. In the given circuit below, the current is I of t equals to 4 sin 500t amperes. The applied voltage V of t in volts is, okay, so V of t they are asking. So V of t is nothing but so the complete voltage. So you will get certain voltage in this one and you will get certain voltage in this one. If you add these two, you will get the complete voltage. Okay, so let's calculate what is that complete voltage. So V of t is equals to I of t into 10 plus I of t into, so this one. Okay, so what is the reactance of this one? That we need to give. Okay, but you see they have not mentioned any of the so source frequency, but here 500t is there. Okay, so that means omega we know. Okay, so omega L, so we can calculate omega L. From that also we can give it here. Okay, so otherwise we have another method. So V of t equals to, so we can give it as I of t. Okay, so 4 sin 500t. Okay, so into 10 it is. Okay, so into 10, that will be the voltage. But in the inductor, what is the voltage? Inductor, the voltage across the inductor we can give it as L into di by dt. Okay, so like this we can give. So what is the L value? 20 millihenry. Okay, so 20 into 10 power minus 3. So into, so di by dt. Okay, so di by dt means, so for the 4 it will be 4 only. So for sine in differentiation is cos. Okay, so for sine differentiation is cos 500t So and for the 500t again differentiation is into 500. Okay, so into 500 it is. Okay, so this is the complete expression for the voltage. Okay, it is the voltage expression. If you have this voltage expression, see they are asking in terms of this only, right? So that's why we need to do in this. Otherwise if they are asking about the value, then directly, so here XL value you can calculate. So R value we have, so R plus XL impedance we will be having, from that we can calculate. Okay, so magnitude of impedance, and similarly multiply that impedance magnitude, if you multiply with this one you will get the, so all the values. Okay, so even this value also we can get like that also. Okay, so anyhow we'll solve in this method. 4 sin 500t into 10 means 40 sin 500t. Okay, so this is the first term, plus 10 power minus 3 into here 500 into 20 is there. Okay, so 500 into 20 means you will get, so 500 into 2 is 1000, 1000 into 0 is nothing but 10,000 it is. Okay, so 10,000 into 10 power minus 3 means you will get 10. Okay, 10 into 4 is nothing but 40 again. Okay, so 40 cos 500 t. Okay, so this is the complete expression. So anyhow if you simplify this one you will get 40 into, so this is sin 500t plus cos 500t. Okay, so this is the one we have. So let's see the options what we have. So okay, 40 sin 500t. Okay, so this is not. Okay, so and 40 cos 500t, this is also not. Okay, so either it may be 56.56 sin 500t plus 45 degree or 56.56 cos 500t plus 45 degree. Okay, so you need to simplify this one even more to get as a single term. Okay, so how it is sin a plus cos a it is. Otherwise so you can simplify using different methods. Convert this cos theta into, this is some theta. Okay, so convert this cos theta into sin 90 plus theta. Okay, we can use it as sin 90 plus theta, like that we can use. Okay, so that means, so 40 into, so this is sin 500t plus sin 90 plus 500t. Okay, so these are the two terms. Okay, so this is like now sin a plus sin b. Okay, sin a plus sin b means, so what you will be getting, see this, you have to know this all things. Okay, sin a plus sin b, cos a plus cos b. Okay, so sin a minus sin b, cos a minus cos b, sin 2a. Okay, so cos 2a. So all these values, sin a plus b, cos a plus b. So these are the things you need to understand. Okay, otherwise you can do somehow. Okay, in signals and systems, some in control systems, in power systems, in machine calculation, somewhere you will be getting these sin and cos terms. Okay, that's why you should definitely know about this trigonometric equation solvation. Okay, so sin a plus sin b is nothing but 2 sin a plus b by 2 cos a minus b by 2. Okay, so this is the one for sin a plus sin b. Okay, so here 40 into, so 2 sin a plus b by 2, that means 1000t plus 90 divided by 2. Okay, so 2 sin, so 1000t plus 90 divided by 2 means again you will be getting 500t plus 45 degree. Okay, so this is the first term into cos a minus b by 2, cos a minus b. Okay, so then 500t will be cancelled, minus 90. Okay, so cos minus 90 divided by 2 means cos minus 45. Cos theta is nothing but cos minus theta. Okay, so cos theta is equals to, otherwise cos minus theta equals to cos theta. Okay, so cos 45 degree is nothing but 1 by root 2. Okay, so 1 by root 2 it is, the value of cos 45 is 1 by root 2. Okay, so if you substitute root 2 under this, root 2 times it will be cancelled, then 40 into root 2 into sin 500t plus 45 degree. Okay, so this is the answer. Okay, so 40 into root 2. Okay, so what is the root 2 value? 1.414. Okay, so root 2 value is 1.414. anyhow the answer we got. Okay, so it should have sin term. Okay, so like this sin function. So answer is like this, 40 into 1.414, if you multiply you will get 56.56. Okay, so answer B is the correct answer for us. Okay, so I told you another method also. Okay, so you can get the resistance value equals to 10 and the reactance value is equals to, so omega L. Okay, so omega L, j omega L we can give. So what is the omega value? See, 4 sin omega t. Okay, so omega is 500. So omega into L is nothing but, okay, see, omega into L is nothing but 500 into 20. So then you will get J10. Okay, so R plus J10 we got. Okay, so this is the impedance value. Okay, so complete reactance value of inductance. So similar to this, okay, so complete impedance we can give it as 10 plus J10. Okay, so 10 plus J10 we have. So current we have, and if you want voltage V of t equals to, so I am just giving directly, so I of t, okay, so what is I of t? 4 sin 500t, okay, into impedance. So you need to represent the impedance. Okay, so here it is, impedance value is 10 plus J10. So you can represent in the angle format directly, right? Okay, so that means 10 plus J10 means a magnitude with some angle. Okay, so angle we can easily get. Okay, so what is the magnitude? So check the magnitude, 10 square plus 10 square. So magnitude you will be getting, so 200 under root 200 means, so you will be getting 10 root 2. Okay, so 10 root 2 will be the magnitude, and angle will be, so 45 degree, because tan inverse of reactance divided by resistance, 10 by 10. Okay, so then you will be getting it as 10 root 2. Okay, so 10 root 2 at an angle of 45 degrees. Okay, so as it is a sine function, directly whatever omega t is there plus 45 will be adding if you multiply these two. Like this also we can do. Okay, if you have clarity about this method, then you can, it is more simple. Okay, so 40 root 2 into sine 500t at an angle of 45 we got, means so directly 500t plus 45 degree. Like this we can do. This is even more simple, but you should have some clarity about this calculations. Okay, so then how? So you can do like this also. Okay, so the next question, at half power frequencies the current in the RLC series circuit is, current in RLC series circuit. Okay, so they are asking, so at half power frequencies, what is this half power frequency? See, so the frequency, okay, the current at resonance generally, so what at resonance, so generally how will be the current is maximum. So let's take series RLC circuit only. Okay, so series RLC circuit they have mentioned current is maximum. Okay, so maximum, so at the resonance condition. Okay, so now when current is maximum means, so what we need to understand here, power, how it is, how is this power? It's also maximum, because power is equals to I square into, so at resonance there is no reactance, so directly I square into R it is. When current is maximum, P is also maximum. Okay, so this is the maximum power. This is the maximum power which is occurring at resonance condition. What they have mentioned at half power. Okay, so half of this power they have mentioned. So that means power at that condition is P max divided by 2. Okay, so to get P max divided by 2, so what you need to get, this current must be, okay, so if you use I by 2, how it will be, I square R divided by 4 it will be. This will not be a half power, it is a quarter power. Okay, so that's why you should not do I by 2. Okay, so you have to get, so to get the P by 2, then I value must be equals to I divided by root 2. What is this I? I is nothing but current. Okay, so current at resonance. Okay, so current and resonance. Okay, so that is the answer. Okay, so where is this option? So current at resonance divided by root 2. Okay, so this is the answer for this. Okay, so at half power they have mentioned, instead of this power they may ask for any other. Okay, so because this half power frequencies are having certain importance in our circuit, that's why they have asked this question. Okay, similar to this, any power they can ask. Okay, so any answer for this question is option B. So next question, on increasing the power factor of a coil, its power factor increases. So okay, on increasing the Q factor of a coil, its power factor increases, its power factor decreases, its power factor remains unaltered, its power factor may be increase or decrease. Okay, so what they have mentioned, so they are asking the relationship between the Q factor and power factor. Okay, so how they are dependent. Okay, so like if Q factor increases, Okay, so what is the Q factor formula for a coil? So omega L divided by R. Okay, so this is the Q factor. Understanding? What is the power factor? So power factor equals to, so active power divided by complete power. Okay, so this is the formula. Otherwise, in terms of impedances also we can give as the resistance divided by the complete impedance. Complete impedance is nothing but R square plus so XL square, or X. This is only coil I have mentioned, so I am just mentioning XL square. Okay, so this is also a power factor. Even from the voltage also we can get. So what is the voltage across resistor divided by what is the complete voltage? Like that also we can use. Okay, so but see here, this is enough to understand. Okay, so here Q factor increases. Q factor increases. So Q factor, how it will be increased? So the resistance in the network will not be changed at any time. Okay, so how Q factor will be increased means based on the omega value. Okay, so frequency changes, so then only the Q factor changes. Once the design of circuit is completed, once the design of any coil completed, resistance value will not be changed and inductance value will not be changed. Understanding? So the inductance value and resistance value, the number of turns and so the wire whatever we have used, we are not changing those things. So inductor and resistance values will not be changed, only frequency will be changed. See here how Q factor increases, because maybe omega increases. Omega increases means when omega increases, XL value, this is nothing but XL only. Okay, so XL equals to omega L. So XL increases. When XL increases, you see here when XL increases, denominator value becomes more, then power factor will become, when denominator is increases, then power factor will decrease. Okay, so Q factor increases means then power factor decreases. Okay, so what is the relationship between these two? So there is a practical relation between these two. So why we need to calculate the Q factor? Why we need to calculate the power factor? So there is certain relation. Okay, so you understand why Q factor will be represented for any coil. Okay, so for example, if I am designing a coil, so which is base for us means the Q factor for the coils. So a coil generally so designed to store the energy. So it's a inductor. Coil means inductor. Okay, so it is designed to store the energy. How much is the stored energy? Okay, so how much is the stored energy in the inductor divided by how much is the energy dissipation in the other parts. Where is other part? Only resistance. Okay, so you tell me, if it is a good coil, then it will be having a high Q factor. So high Q factor means it will be having less resistance. Understanding? If it is a good coil, it will store more energy. It will not waste any energy. Okay, that means energy, the heat dissipation in that coil will be very less. That's what it means. Okay, so if it is a good coil, Q factor will be high. Q factor will be high means R value will be less. Understanding? So at the designing stage, okay, so if I am designing a good coil means the resistance or power dissipation in that coil must be less. It has to store energy, it should not dissipate energy. That's why we used to represent the Q factor. Okay, so if it is designed, if any coil is designed for high Q factor means it is designed to store the energy. Understanding? It is designed to store the energy. So it is designed for storing of energy means it will not take more active power. Understanding? So it's a design property. Okay, so once the Q factor increased means, that means it will not consume more active power. That's a direct consideration. No need of all these analysis. Okay, Q factor is high, that means it's designed for storing high energy. It's not for the dissipation of energy. Okay, that means resistance value must be less for that. Okay, so like that we have to confirm. When resistance is less, active power consumption is less. So it is designed to store, it is not designed for the energy dissipation. Okay, so that's why whenever Q factor is high, power factor will be less. Okay, so directly we have to remember this. Okay, so no need of all these again and again. Okay, so there are certain understandings from this, but still directly from the concept we need to get this answer. Okay, so anyway, answer for this is its power factor decreases. Okay, next question for an RLC series circuit, current at series resonance is, okay, so we have already discussed this. So for an RLC series circuit, current at series resonance is, okay, so current I at series resonance, so generally current value will be given as V bar by Z, okay, so what is the Z value at resonance? Z, generally Z will be R plus J into, okay, series resonant, right, okay, so it's a series resonant circuit, so plus J into, so XL minus XC, it is under resonance condition, XL is equals to XC, so Z value equals to R, okay, so it is at resonance, okay, so at resonance. So previously Z value is nothing but magnitude of Z, previously it will be under root R square plus XL minus XC whole square, like this we have to write, okay, so not separately, so like this we have to write magnitude. So now it's magnitude Z equals to only R, okay, so now under resonance condition Z value decreases, when Z value decreases current increases and current will be maximum, okay, so this is enough. So current will be maximum, and what is the power factor? We know already. So R only will be having reactance, we are not having. So maximum at unity power factor. This is the correct answer, okay. So what they are asking? So current at series resonance is, okay, it is maximum and at unity power factor. This is the correct answer, okay. So next question, what will be the power consumed by the voltage source, current source and resistor respectively, okay. So this kind of question we may expect from the GENCO examination, okay. So what is there in this question? See, so more number of, okay, so more number of answers they are required, okay. So that means we need to solve this definitely. We should have some analysis about this very simple question, okay. So even in the SSC JE mains examination, okay, so this question is possible to come, okay. So understand, okay, so importance of this question. So we may know directly what is the voltage across this resistor, what is the voltage across this current source, but what is the current going in this 1 volt source, voltage source, we don't know, okay. So that's why they are asking all the three, okay. Now let's see what they are asking. So the power consumption, okay, power consumption, let's take about resistor first, okay. So power in 1 ohm resistor is nothing but, anyway voltage across this is nothing but 1 volt, so voltage square divided by resistance we will use, okay. So V square 1 square divided by 1, so that will be 1, okay. So first one we got, okay, voltage source we got, okay. So next one, not voltage source, it is in the resistor, okay, so resistor. So next we will see across the current source, okay, so current source, so current source I. So power in the 1 ampere current source is nothing but voltage across this is 1 volt and current is 1 ampere, so we can give it as voltage into current, that will be equals to 1, okay. So it will be in the watts, okay, so 1 watt. So this is also we know, okay. So now the third one, so what is the current in this one? That's what we need to understand, okay. So what is the current in this one, okay. So for the voltage source, so power in the 1 volt voltage source, what we have to use? We have to use V square by R, otherwise V into I, otherwise so we have to use the I square into R, anything we can use. But you observe, if you can find out the current in this one, if you can find out the current in this one, okay, so then you can easily get current into, so the voltage value, so that will give the power for us, okay. But you see how to calculate the current in this one, we need to use certain method, right, okay. So we need current only in this one, okay. So what I will do, we can use whatever you want, you can apply without disturbing this voltage source, without disturbing this current, okay. So without disturbing this branch, we can do whatever we want to the other thing, okay. Like 1 ampere and 1 ohm are connected in parallel, we can make this circuit as, so 1 ohm in series, in series with a voltage source of 1 volt, like this we can use, okay. So this is the 1 ohm and this is 1 volt, understanding. So instead of this circuit, okay, so instead of this circuit, now newly, okay, so we have to give it like this, okay. So we need to give it like this. This is the 1 volt source. Now we have the 1 ohm resistor here, and again another voltage source will be here of 1 volt. How we have changed this? Current source in parallel with resistance can be transformed as current voltage source in series with same resistance. Voltage source value is 1 into 1 1, current this resistance value is same as 1 ohm. Here 1 volt is there, here also 1 volt is there. Current going here is nothing but 0 amperes. Okay, so 0 amperes will go like this. Okay, so this is so much simple only, but in time we have to do. Okay, so and remember, you will not get idea. Okay, so how much is the power consumption by this one, how to solve this, no need of this. Okay, instead of I know, okay, current equals to 0 here, so answer for this also equals to 0 watts. Okay, so that's okay, no problem. Okay, so why to do only like this? So similar kind of problem in GENCO also they have given previously. Okay, so like so the current going in this element only they have asked. Understanding? Current going in this one is nothing but 1 volt divided by 1 ohm is nothing but 1 ampere. Understanding? So 1 ampere current is going like this, 1 ampere is current is coming like this. You see, okay, so how it is, this 1 ampere is coming and this 1 ampere is going like this. So what is the current going in this one? Directly it's equals to 0. Okay, so we can understand why to do only like this. So we will solve in a different method. Okay, so here current equals to 0 we got. Okay, so I want current in this one. Okay, so this is 1 watt, this is 1 watt, so I want current in this one. So first I will activate only this source. I will deactivate the current source. Okay, see, I am giving the different methods to solve. Okay, so then we will get the idea in the examination. Okay, so I will deactivate this one, then only this will be there. So 1 volt in series with 1 ohm, so how much current will be flowing like this? 1 ampere will be going in this direction. Okay, so see this direction. Okay, 1 ampere in this direction. Now I will deactivate this one. Okay, so deactivation means short circuit. Okay, so short circuit the voltage source. When you short circuit, 1 ampere will come like this, 1 ohm no current will flow. Okay, so by using which theorem we are doing here? Superposition theorem. Okay, in second case 1 ampere will be flowing in this direction. That means one case 1 ampere, in one case 1 ampere like this. So total current I equals to 0. So how I am writing I equals to 0? The total response is equals to sum of the individual responses using superposition theorem. Okay, so how we will get all these ideas in exam? So with the practice only we will get. Okay, so remember, with the practice, whenever you see certain problem, they are asking about current, they have given certain solution, you need to try for the different solution. Okay, so then you will definitely get the answers very fast. Okay, so it may be long procedure you are doing while learning. Okay, but in the examination you can do it very fast. Okay, so anyhow, answer for this one is, so they have asked in a sequence. Okay, voltage source, current source, resistor. Okay, so voltage source, current source, resistor. Okay, so 0 1 1. Okay, so 0 watts, 1 watt and 1 watt. Okay, this is the answer for this question. Okay, so the next question, what will be the value of XC so that the circuit is non-inductive? Okay, so non-inductive they are asking, so XC value they are asking. Okay, so that means here what is the value? Okay, so like that they are asking. If you check between these two terminals, what is the, so if they, it has to come as only resistive. Okay, so because they told non-inductive, that means only resistive part must come here. Okay, so anyhow, J5 and 2 both are connected in a series. Okay, so then complete impedance is equals to 2 plus J5, it is plus, these two are connected in parallel. Okay, so these two are connected in parallel, so whenever these two are connected in parallel, so you need to give it as, so J5 into minus JXC divided by, so J5 minus JXC. Okay, so like this one, these two are connected in parallel. Okay, that's why we have given like this. So these are all the imaginary part we have, and this is the only real part. But you observe one thing, if you simplify this one, you will get some more imaginary part also. Okay, so let's simplify. J into J is nothing but J square is minus 1, minus into minus is nothing but plus 1 it is. Okay, so directly, so we can get it as plus 2 into J5 plus XC. Okay, so 5XC. Okay, so remaining all term will be cancelled. Okay, so here also we will be having, so J into 5 minus xc. Okay, 5 minus xc it is. Okay, so this is the one. So here j is there in the numerator, it will, if you take, then it will be minus j. Okay, so then the complete one will be 2 plus j into 5 minus 5xc by 5 minus xc. Okay, so 5xc divided by 5 minus xc. This is the complete one. Okay, so complete impedance, and they told it has to be non-inductive, means this all part must be equals to 0. Okay, so we need to do 5 minus 5xc divided by 5xc divided by 5 minus xc equals to 0. Okay, so this is the one. Anyhow, 5 minus xc, if you take like this, you will get as 25 minus 5xc minus 5xc equals to 0. Okay, so it will go to other side and multiply with 0, 0. Okay, so then 10 xc equals to 25, xc equals to 2.5 ohms. Okay, so xc reactance value they are asking, so it will be 25 divided by 10, you will be getting, so it will be 2.5 ohms. Option A is the correct answer. Okay, so we need to follow the procedure, that's it. Okay, no other method is there for this. Okay, even though some shortcut is also there, okay, but it will not be useful for you, so you will confuse whenever, if anybody knows, okay, you try with the shortcut about this one. Okay, so next question, the equivalent circuit of the following circuit is. Okay, so equivalent circuit they are asking, so for the following circuit, so between AB terminals. Okay, so these are the AB terminals, must be, they must represent here also. Okay, so AB, otherwise if it is not AB, then it's different answer. Okay, so if you take the equivalent resistance between these three, so all the voltage sources must be short circuited. So R in parallel with R in parallel with R is nothing but, so you will be getting R divided by 3. R equivalent is R divided by 3. Option C is the correct one directly. Okay, so otherwise even you can calculate the voltage also. Okay, so between these two terminals, what is the voltage? Between these two terminals, what is the voltage? If you check, you will get the, so even voltage value also. Otherwise, what is this one? It is nothing but Milliman's theorem. Okay, so Milliman's theorem it is. Okay, so for the Milliman's theorem, so it is also called as parallel generator theorem. So the complete voltage is nothing but, okay, so there are formulas, right? Okay, you can even directly so give that. Okay, so you can convert voltage source in series with resistance as a current source in parallel with same resistance, then we can get it as easily. Okay, so here V by R, V by R, V by R, 3 resistances. Okay, so 3 current sources, V by R plus V by R plus V by R, all the 3 resistances are connected in parallel, then you will be getting R by 3 between these 3 terminals, these 2 terminals. Okay, sorry. So then again you can convert V by R, V by R, V by R is nothing but 3V divided by R in parallel with R by 3. So 3V divided by R into R by 3. Okay, so is equals to, it is the voltage source value. Okay, so it is the voltage source value in series with R by 3. Like this we can represent. Okay, so R will get cancelled and 3 will get cancelled. It is the value V in series with R by 3. Okay, so like this you can able to do. Okay, so answer for this question is option C. Okay, so this is what about the circuit questions. Okay, so even though, so for this examination there are some more questions which are important for us, so we may not cover some of the models. So if you notice some of the questions, you just message to us. Otherwise you can you can bring notice to us, then we will try to discuss those problems also. Okay, so anyhow some more concepts also there, like 2-port networks also there, like some of the questions will be coming from the transients. Okay, so very less questions from the transients from these sections actually. So anyhow we will try to give those questions also in a different module. Okay, all the best, thank you so much.